sections in this first exam. So 7.4 is adding and subtracting fractions when they've got x's and things like that in them. So what do you remember about adding and subtracting fractions? What does it take to add and subtract fractions?
Common denominator. Lowest
common denominator, right? You got to have common denominator. So let me rewrite this one over here. 42 over 7x plus 15 over 5x. Yeah, so I've got to make those two denominators be the same, huh? So what am I going to do? What can I make 7x? So I'm looking at 7x and 5x, thinking, got to make them the same. Because you can't add or subtract fractions unless the bottoms match, huh? Yeah, you could do some reducing. Oh, actually, you could on this one, huh? I didn't think about that. Yeah, these are 7 goes into 42 6 times. Now, this isn't normal. Normally, we don't reduce, but that's a good observation. I didn't think about that. 5 goes into 15 3 times, huh? So this is 6 over x, and this is 3. Yeah, that was nice. I didn't think about that. Yeah, now it's not normally going to work that way. That's a trick that's not normally there. So 6 over x plus 3 over x. So that was nice. It just automatically became common denominators when we reduce those fractions. Again, not typical. So now we can add them up, and it's 9 over x. That's the answer. Because then the bottoms match, huh? So once the bottoms match, you can just add them, right? Okay, let's try number 2. That trick won't usually work. So number 2 now. So so one of them has a plain x, and the other one has a 4x squared. So what do we do to the top and bottom to get those to be the same?
Do you just times 4x?
You factor the bottom?
Yeah, so I'm gonna come over here and multiply 4x and 4x, top and bottom of the left fraction. Does everybody see that? Is that making sense? What I'm doing, because 4x times x will make that one 4x squared, and then they'll both be 4x squared. I won't need to mess with the fraction on the right at all. Is that good? Can you guys all see that okay? Anyway, is that good? Is that making sense there? So that'll make the two denominators the same, and then you can add them up.
No, just one number. Yeah.
So we'll get, what is that? 28x over 4x squared plus 5 over 4x squared. See how that makes the two denominators the same? Hey, why do I have to do the top and the bottom?
So when you can add it.
Why whatever I do in the bottom, I have to do in the top?
Because that's how math is.
Anybody know? You guys don't just do what math teachers say blindly.
Well, you have to apply it for both terms, the bottom and top. Right?
So you guys just keep repeating to me the rule. And my question is, why? Who made that rule, and why do we have to follow it?
You made that rule.
What's that? Right? Yeah. So I like the way you're talking. It's about what's true. So I hope really you don't follow me or any other math teacher blindly. Don't put that much faith in me, but follow the truth, completely, with complete allegiance, and you'll be good. Now, hopefully, I will be giving you truth. But do you see why? If I have a fraction, say like 2/3, and I multiply only the top by 2 and not the bottom, becomes 4/3. Is that the same as it was? No. But if I, like you said with numbers, if I also multiply the bottom, it becomes 4/6. Now, what's 4/6?
It's the same as 2/3.
That's the same as 2/3. You could reduce it, and it would go right back, huh? If you said I had a pie, let's be real here, as real as we can. Did you guys have a pie as you watched the Super Bowl? I didn't have any pie. Maybe that would have made the Super Bowl more enjoyable. So if I said, hey, I ate 2/3 of the pie. How much, so say the pie is cut into 6 pieces. How much is 2/3 of that pie? You know, if I say there's 1, 2, 3, 4, 5, 6 pieces. I had I was so hungry, I just ate 2/3 of the pie. How would you do 2/3? isn't this first off 1/3 of the pie, right? You can see, if you break it like this, those are third sections, huh? And so then this would be 2/3. Isn't that 2/3 of the pie? Which is what? Same or different than 4/6 of the pie? Two different ways to say the same thing. So when we multiply top and bottom of a fraction, we're not changing it. So that's why we do that, huh? Because we can't be changing the problem. We can change the way it looks, but we can't change what it is, right? Does that make sense? That's why we do top and bottom. I think it's always more enjoyable to know the reason why, and then it'll stick with you better, I think, too. Right? So the deal is, I want to change the way this 7 over x looks. Why? Because I got to make the bottoms have the same look. But I can't change what the fraction actually is, right? So I do the same thing to the top that I do to the bottom. So it doesn't actually change, it just looks different. Okay, so with that in mind, now we can add the two fractions together. And what do they equal? Well, you just kind of make them one big bar. I mean, there's really not much to do. Done. You just make it one big fraction with the same denominator. Does that make sense? That's just it. What did we do? We added them. Really, we just kind of put them together, didn't we? Into one fraction. Hey, why can't I come in here? Why am I saying we're done? Can't we cancel all these x's?
No.
Why not?
The plus sign going together.
Yeah, plus sign, because Costco says no. Right? I mean, really, there's truth there, too. I think I showed you that. Yeah, the rule we learned about pluses and minuses, glue things together, make them a package deal, and you buy all of them. If you want to mess with this 28x plus 5, you cancel it all, or you do nothing. Right? It's all or nothing. You can't say, I just want the x, please. No, it's all or nothing. It's glued together package deal. Yeah?
So the reason that you did it the way on number 1 was because they could go into each other?
Yeah.
So when you can't, then you do them.
Yeah. Really, I hesitated to show you that at number 1 because that'll never happen again. That was a totally weird case. They'll never go in again. You're right. Good to McKinsey. Exactly. Yeah, it's because, they'll never go in again. That was totally bizarre. Normally we just do top and bottom. Just top and bottom, whatever it takes to make the bottom. That's the way it'll always be. Number 1 will never happen again. That was a special one. Good so far? Is this making sense? So what we do is we do top and bottom to make the two denominators the same, then you make them one big fraction. On number 3. Oh, hey, the middle thing came on finally. Woo! It just takes a while, doesn't it? All right, so what needs to happen on number 3? Look at the denominators. One of them's meaty. What do I talk about?
You have to multiply by -1.
This guy, x squared minus 1, needs to be factored. Yeah. 2 parentheses, right? Yeah, you got to do that first. So so I'm going to write some steps out. Maybe it's getting to be time. So yeah, let's do that. Here, let me write some steps for you, and I'll put these on the board too. So add, subtract, and I'll go back to the question 1 second. Add, subtract. Step 1, factor denominators. Step 2, multiply top and bottom I'll just say by what is missing. So multiply top and bottom by what is missing. Step 3, multiply out the tops and gather like terms. Step 4, reduce. Well, here, let me change what I say there. Factor denom and reduce if possible. It's usually not. If possible, usually not. Okay. So there we go. So there's the 4 steps. So this part right here, x squared minus 1. So how does it factor? Yeah, x plus 1, x minus 1, right? It's the double-double. Is that good? One positive, one negative to make negative 1. We good there? Okay, so then what do we have? So 2 over x plus 1 minus x over x plus 1, x minus 1. Good so far? And now we're going to multiply. So that's step 1. Step 1, factor denominator. Step 2, give them what they're, the way I say it is give them what they're missing, or multiply top and bottom by what's missing. So we're going to look at this denominator here. I didn't write it very well. We're going to look at that first denominator. We're going to say, okay, I'm going to multiply top and bottom of that guy, and then I'm going to come over here and multiply top and bottom of that guy. Turns out by nothing on the second one. But let's look at the first one. So on the first one, I'm going to multiply top and bottom by whatever he's missing that the other one has. Because I want to make them the same, right? So what is this one missing that the other guy has? X minus 1, huh? Top and bottom. Does that make sense? If you give him a parenthesis x minus 1, top and bottom, whatever you do, you got to do top and bottom. So we're not changing anything. We're not changing that fraction. We're just changing the way it looks. But now it matches the other one, doesn't it? It has the same denominator as the other one. So it's like you're making them the same. What does the other denominator have? What does the other fraction need?
2.
Nothing. No, just the bottom. We don't care about the tops. We don't care about the tops. Just the denominator. What does this one need? Nothing. It's good. Does that make sense, what we did there? So I multiply top and bottom by whatever it's missing. Now the two denominators match, don't they? All right, that's step 2. Go on to step 3, which is now multiply out the tops, not the bottoms. By the way, notice it doesn't say bottom. Once you've got the bottoms matching, don't mess with them anymore. They're good. Don't FOIL out those bottoms. Don't do anything with those bottoms. That is the common denominator. Leave it. We're good. But now all of our attention turns to the top, the numerators, and we multiply out, meaning that 2, that 2 is going to multiply both those, and then minus the x, put them all together, like terms, all that. Make it into one fraction now, right? All that? That's step 3. Multiply out tops and gather like terms. Just the top. Only the top. So when I multiply that 2, what do I get there? I get 2x minus 2, right? It hits the x, hits on 2x minus 2, minus x, all over the common denominator. X minus 1, x plus 1. Good so far? That's step 3. Is everybody seeing that? So step 1, I factored the denominator. So I can, if it helps you, I can write the steps there. So this is step 1 right here. I factored the denominator. And this is step 2 right here. I multiplied top and bottom by what was missing. And then this is step 3, almost done. Actually, we have a little bit more in step 3, right? We've got to continue to gather like terms. We're doing the top now. Notice the first 2 steps are all about the denominators, factoring denominators, making common denominator, right? And then forget about the denominators. So the first 2 steps are all about the bottoms. The third and fourth step are all about the tops, right? First 2 steps are getting a common denominator. Once you've got that, then just move. All of your focus goes up to the numerator, and you multiply out, gather like terms up in the numerator. And so what's that going to give us? 2x minus 1x is 1x minus 2 over x minus 1, x plus 1. So there's the end of step 3. I gathered like terms up top. Now, step 4, usually you don't have to do. That's why I keep saying try if possible. The last thing you're supposed to try, but it almost never needs to be done, is try to factor the top. can you factor that? Notice this process begins and ends with factoring. We start by factoring the denominator, step 1, and we end by trying, usually we don't, try to factor the top. Can you factor that? No, that doesn't factor. X minus 2, there's nothing in common. There's no GC up there. Done. We're done. So usually the top doesn't factor. And there's our answer. You don't need that 1 in front of the X. You can get rid of it. It's just X minus 2. Same thing, huh? Is that good? Is that okay? Questions on that? So step 1, factor the denominator. Step 2, multiply top and bottom by what's missing to make the denominators match. And then, once you got that, go up top, multiply everything, gather like terms in the top. It's one fraction. So what did we do? We just made the two fractions, bottoms look the same, so we could combine them together. That's what we're doing. To add, subtract fractions, you've got to make their bottoms match. All right, shall we go on? Questions I can answer? All right, to number 4. There's the steps. So, yeah, this is a good reminder of something we did, I don't know, sometime last week, I think. As you look at those denominators, and you remember anything from last week?
No.
This time, B is equal to...
Yeah, the -1 turnaround trick. Remember the turnaround rule or trick or whatever? See how remember you never want the way it is on the one here on the right. You never want the letters subtracted at the back. You want it like it is on the first one. You want the letter in the front. You don't want the letter in the back. Remember, whenever, at any time, they give you the letter, so I can write that rule again. When the letter subtracted at the back. Now, this time I'm going to do it a little different. Multiply -1 over -1. So I'm going to come to this fraction and multiply by -1. I think I told you before, it's something with a -1. But this will be the easy way to handle. Just multiply top and bottom by -1. And this is called, let me give you the name. This is called, again, the turn around rule. And what it does, it turns it around because you don't want the letters at the back. You want them in the front. Now, really, there's no important reason for that. Really, I just want them to be the same. You really could put them both in the back, and that would be fine. But just to make it nice and orderly, let's just always put the letters in the front. So, okay, that'll do it. When you multiply by -1, that'll flip it around. There's two ways you can do that. You can say, look, I'm not going to mess with it. I'm just going to say it flipped around. You're right. And that's -3 on the top. The other one hasn't changed at all. Is that good like that so far? So the first fraction didn't change at all. No change at all. The second fraction, multiplied top and bottom by -1. So the top 3 became -3. And the bottom turned around. If you want to see more detail on like why'd that turn around, you can just distribute. You'll see it. See that what you don't have to do this though, not required. But see that would become -8 plus b, which is the same as b minus 8. Do you realize that's the same as b minus 8? You don't have to show all that. Not required. You could just say, look, you multiply by -1, it flips it. There's why it flips it. Because if you multiply both them by -1, it'll become -8 plus b, which is exactly the same as b minus 8. Now you might wonder, why do I say that's the same as b minus 8? Remember, all that matters really is signs in front of a number or letter or whatever. Order doesn't really matter. I know we feel like it does, and I'll say things which sort of seem like I'm caring about order. Really, it doesn't. You can shuffle things around all day long you want. It doesn't make any difference as long as you took the sign in front of them. So they got a minus or they got a plus in front of them, on the left of them. Take that with them wherever they go. It's all good. You can do it in whatever order you want. Did you understand all that? Order doesn't matter as long as you take their sign with them. So that's why I say -8 being in the back, it's still -8. Positive b, what's in front of this b? Nothing, which means plus. That's the same, huh? Which is different than it was. Back here it was different. This was a +8, wasn't it? Now it's become a -8. So you see, multiplying that by that -1, really, it changed both signs. That's really what flipping around I probably over-talked it. So just flip it around. Flip it around. It's all good. Multiply top and bottom by -1. It'll flip around. Now, how do we finish this problem?
You just add it.
Yeah, they already got the common denominator, don't they? I don't need to mess around. So 1, take away 3, -2, done. Can I divide 2 into 8 there?
No.
Why not? Costco says no. It's a glued package on the bottom.
Costco versus Walmart.
All or nothing. Good? All right, let's move on. Number 5. What are you going to do first on number 5? Same thing. Do that first. First turn around. Before you do any factoring, get that thing turned around. Right? See how he needs to turn around? We don't want the x's subtracted at the back. So multiply top and bottom of him by -1. Same kind of thing. Get him flipped around. That'll flip him around. Okay, so we come in here and we say -1, top and bottom, because I want to turn that thing around. So you don't need to show all that stuff I showed, just flip it around. So I'll just bring the first fraction over here. It'll be -7 over x squared minus 5 minus. And then the second fraction will become -6 over x squared minus 5. So far so good? I just multiplied -1 times 6. That made -6. And -1 times this turned it around. Huh? Is that good? Because it changes both the signs, which is what that does. All right. So now, now you don't have to factor this one. Why? Well, it's because they already match. All that, all those steps I gave you about factor, denominator, that's when they don't match, because then you got to work. So -7 minus a -6. Yeah. So these two make +6. -7 plus 6, -1 over x squared minus 25. And there we go. Is that good? Does everybody see what happened there? Questions I can answer? You good? Please speak up if you're not good, or you just have something that's bugging you bad. All right. All right, let's go on to number 6. So now we're supposed to add those two on number 6. But what do you do when you have a whole number like that 5 there, You got a whole number that's interacting with a fraction. What do you do? Put it over 1. Make it look like a fraction, huh? Just put it over 1 and then work from there. So take it from there. So is there any, so looking at our steps, our 4 steps, step 1, factor denominators. Does that denominator, is that factorable? No, there's no GCF or anything. So skip step 1, go on to step 2, multiply top and bottom by whatever's missing. Multiply. You're not adding things though, you're multiplying, right? Is that good? That'll make the two denominators the same, won't it? Give them what they're missing. Take it from there. Okay, so we put this one over 1. That's what we always do when we have a whole number, to make it look like a fraction. And then we do the step 2, multiply top and bottom by the same thing, because give them what they're missing. So this fraction on the right is missing the x plus 9 that the other one has. That'll make the two denominators the same, won't it? Does that make sense? We multiply top and bottom by whatever's missing to make the two denominators the same. And so where does that leave us? That gives us common denominator x plus 9. They both have it. So now our attention turns to the top, doesn't it? Forget about the bottom. We've got a common denominator in the bottom. We're good there. Now we just work with the top. 6 plus, and this 5 will distribute. 5x plus 45. What's that? 5x plus 51. Can I cancel anything? Nah, it's all glued. There we go.
I have a question.
Question?
Why wouldn't we factor out the 5 when we get 5x plus 45? Is it because it's moved by that plus sign?
Well, it's simply the order. Notice that's factoring in the top you're talking about, right? And where is that in the steps? 4. Try to factor. Oh, did I write denominator? That should be top. That's a problem. Yeah, so the fourth step is the only time we think about factoring the top. Remember, the first 2 steps are all about the denominator, and step 3 and 4 are all about the top. So my point is, first you've got to gather like terms in the top. Step 3, before you think about how you factor. So instead of factoring out this 5, first gather the like terms, and then we would factor the top at the very end if it was factorable, but now it's not.
But not before when it's.
But not before. Yeah, first gather like terms. That makes sense? So the process begins with factoring denominators and ends with factoring numerators. But usually we don't have to do that last step. Questions on that one? All right, try that one. So the name of the game is to make the denominators match. So go through the steps. Step 1, factor denominators. Those denominators don't need to be factored, do they? The x and the 8x, there's nothing to factor. Do you know what I mean? There's no GCF or anything. Right? Am I confusing you with that? Well, you would only factor if you had something like 8x plus 12. You know, then you would take out a 4 or something. You know, we have nothing to factor. Skip step 1. Go right on to step 2. What's step 2? Give them what they're missing, top and bottom. So you should be looking at these guys and saying, what are they missing? What are they missing? What is this one's looking over here at his neighbor. Do you ever look at your neighbor and say, what do they have that I don't have? You shouldn't do that. It's not a good plan. My neighbor has a very nice car. Has a Mustang GT. The engine just rumbles. And I either drive the old family van, is what I used to drive, and I have nothing like that. But I have 5 children; he has 1. So I think that's the difference. I think if I only had 1 child, I could afford the nice car. So anyway, so every now and then I think it'd be nice to have that car. So compare to your neighbors and take what your neighbors have. That's the moral of the math story here. Make it the same. So I'm trying to help it stick in your mind. So compare. And give them what they're missing, right? So what is this one missing that the other one has? Well, just the 8. So top and bottom by 8. Am I making sense? Multiply top and bottom by whatever's missing.
Right? Isn't it? Because what I did was -8 minus 1x. So that made 9x.
So go on from there.
Right, but that minus distribution.
So that would be
Good so far? That reminds me, this one has a special trick.
But I'm waiting for the next step. I think
So remember what we're supposed to do. So step 1, factor denominators. Didn't have to do that. Step 2, multiply top and bottom. As soon as we've got common denominator now, don't we?
No, because that minus.
As soon as the bottoms match, where's all the rest of our work happen?
No.
On top.
Okay.
Just forget about the
So now
bottom.
it's going to be
All the rest of the work is on top. What do I do on top now?
-9x
Yeah. Multiply out, gather like terms, right? That's step 3. Multiply out the tops. Gather like terms. It's making sense? So what do we get? When I take that minus, or that 8, and multiply, I get minus 8x plus 48.
Yes.
Like that? Is that good? Minus 8x plus 48, we good? Okay, now here comes the trick. Are you guys ready? Are you feeling tricky tonight? So what are we supposed? We're supposed to combine like terms on the top, right? Okay, so we should this one first. No big deal there. Minus 8x plus 48. Now, what does this minus do? Goes to both. It's minus x plus 7. That's a really common mistake. Watch out for that. Does everybody see that? Why does that happen? Well, because you've got to subtract the whole fraction on the right, not just the front part. Right? You're subtracting the entire fraction in the upper right, not just the front part. It's very, I mean, that might be the most common mistake in all of algebra, is that right there. Subtracting fractions, forgetting to go all the way through the one on the right. So minus signs in the middle, they distribute to both of those, changing both signs. And now just finish it up. So now we just go, okay, it's going to be minus 8x minus 1 more x is minus 9x. 48 and 7, what's that? 55 all over 8x. Done, right? Nothing more to do. Can't cancel. It's Costco glue and done. Good? Getting the hang of this? It's all about multiplying top and bottom to make the denominators match and then combine all the stuff on the top. All right. Try number 8. Question?
Do we have to get rid of that negative sign in front of the 9, or is that okay?
No, it's okay. Yeah, it's okay there. Try number 8. Same kind of thing. Got to make the denominators match. So we're going to multiply top and bottom of that guy, right? What are we going to multiply by? What is he missing to be the same as his neighbor here?
3.
He needs a 3. But we're not even looking at the top. We don't care about tops. We're just looking at 7 to 21. We're just only bottoms, right? It's common denominator we're looking at. So you just say, what does 7 need to become 21? 3. And then you got to do a top and bottom so you don't change the fraction. You just change the way it looks. Okay, take it from there. Now the two denominators should match. And now you can go to the top and do the work on the top.
Okay.
Maybe I'll rewrite this one. So number 8. 3 support over 7. 5 support over 21.
And then you have to change that second term. Because this is x squared divided x to the 4th. Right? Yeah.
And so then we just combine them, right? Done.
Okay, then no. Okay, so you just go straight across.
Oh, yeah, you guys are wanting to factor the top?
Factor the top or do multiply?
Yeah, you don't. I'll explain. Everybody good to there? Is everybody good to there? Does that make sense to there what we did? So I just multiplied top and bottom to make the bottoms the same, and then I just combine the tops. Now, yeah, good question. Now notice carefully what it says in step 4. Try to factor the top and reduce if possible. In other words, let me say that better. What that means is, at this point, if I fiddle around with the top, okay, if it makes something cancel, if it makes something reduce. If nothing cancels, then forget about it. So let's try it. So could I factor that top? Yeah, actually I could do a couple things that'll go nowhere. Let me show you. You could take out an x squared first off. That's a GCF. That'd leave 3x squared minus, or 9x squared minus 25. It'd actually be GCF first, not double-double first. And then you would do the double-double. And that would be 3x, 5, 1 plus 1 minus. But none of that, so now we're to here, none of that will cancel with a 21 in any way, shape, or form. So forget about it. There's our answer. Does that make sense? The factoring in the top only matters if it makes the fraction reduce, get simpler. We're trying to simplify, trying to say it simpler. If it doesn't make things cancel and simplify, then it's a waste of time. Don't even bother with it. I mean, it's good we looked at it. It's good we examined it and tried to see if there was something that would cancel, but nothing canceled. So just leave it as it is. I mean, any of the versions are fine. Really, any of those answers are good, is what that means. So you could give the answer this way. That's still right. Or this over 21. That's okay, too. All those are right. Math Excel will take any of them.
How come you can't do the 9x minus 25? Is it because the exponents are different? If the exponents were the same, can you do it?
I did the 9x minus 25. I did it right here. 3x plus 5, 3x minus 5, you mean?
No, like
Combined
the whole
terms.
thing. Yeah, like 9x. Why can't you?
Wait, I'm not sure what you want to do.
She can't
It'd be like, yeah, like it'd be like negative 16.
Oh, yeah, because the power's different. Yeah. Yeah, good question. Totally. You're right on the money. Yeah, it's because if those are the same, if that was like fourth, then I would subtract and get minus 16x to the fourth. Yeah.
So the exponent is half.
Yeah. Like terms have to have same powers. Yeah. So we'd say these are unlike terms, different powers. Really good question. Yeah, I see. Yeah, right? Everybody see that? That's why I couldn't subtract these, because they were different powers, so they're unlike terms. They have to stay separate. Yeah.
And
Good.
also because the minus symbol, you cannot do nothing more.
Right. You can't
You
cancel.
have to keep it like it is.
Yep. You can't. Yeah, you can't go like divide by 3 or anything. Yeah, because of the glue on the top, huh? Makes it a all or nothing deal on the top, package deal, and we can't do it all, so we do nothing. Yep. Getting the hang of all these rules. So usually that last step of factoring the top, we don't have to do. Usually once you get a common denominator, just gather like terms in the top, you're done. Usually. 99% of the time. Every now and then a weird one will factor on the top and reduce. But that's rare. We're done. Number 9. All right, try that one. 6 over 5v plus 7 over v minus 9. So you know the name of the game. Make those denominators the same.
Denominators are the bottom, right?
Denominators.
So they need a 5.
So we times it by 5.
The second term goes by 5, no? Yeah.
In fact, let me just rewrite this and give a little more room. What was it? 6 over 5v plus 7 over v minus 9. Okay, so first, going through the steps again. Step 1, factor denominators. This doesn't need to be factored. Step 2, give them what they're missing, top and bottom. Okay, so let's come to this guy, and he's going to look at his neighbor and say, all right, what does my neighbor have that I don't have? Yeah, now, could I say, well, I've got the v part, but I just need the minus 9. No, remember? That's a glued package, right? You in no way ever think about v and minus 9 as separate. This is Costco when there's pluses or minuses. You buy the whole v minus 9 or you don't touch it, right? So I need the whole v minus 9, top and bottom. Does that make sense? And then I come to the second one. Put this back the way it was here. Then I come over here to the second one.
Also, there's 2 steps.
Yeah, so this one we're going to have to give something to both denominators. They're both missing stuff. Like I'm missing my neighbor's car, and he doesn't have as many kids as me. I'll trade some kids for the car. And then we'd all have the same stuff. All right. So what does this one need that the other one has? The 5 and the V. He doesn't have a solo V. He needs the solo V, which is different than a V minus 9 package thing. Top and bottom, so that we're not changing any fractions. Does that make sense? There's a difference between a solo V and a V minus 9 package. They're just totally different. So notice there's something important, huh? When we see the way we look at this is why we did all the Costco talk to help you. So what that means is when you look at 5 and V, you need to think they're separate. I don't need to keep them together. That's save mark. You can have just the 5 separate, the V separate. They're totally, totally separate. But when I look at V minus 9, I think package. V minus 9, no separating. See how that works? Pluses and minuses.
That's how I started, but I just put
5 and V are separate, V minus 9.
So,
All right, take it from there. Now the denominators match, so forget about the bottom. Just work with the top.
see the denominator now the same.
Bottoms have the same. Doesn't matter what order. There are different orders, but that doesn't matter. We have common denominator now, don't we? Denominators are the same. So now just multiply out the tops.
So it's gonna
Gather like terms.
okay, we make a line. B minus 9 times 5 minus 3. And we will have B minus 63, 54. Right?
Yeah?
Plus.
So multiply out the top, right? Boom, boom,
See?
boom.
Kaboom.
Multiply out the tops and gather like terms. My writing's a little sloppy here. So gather like terms in the top. So what do we get? 6V minus 6 times 9, 54. If you're rusty on that, you can use calculators and tests and everything. Plus 7 times 5V, 35V.
B.
We good to there? That makes sense? So we got a common denominator. And then we're done with the denominator. And we just multiply out the top and gather like terms. Almost there. 6V and 35V. 41V. Right? Now, yeah, minus 54 over 5V. V minus 9. Done.
You wouldn't multiply out the 5V and the V minus 9.
Yeah, good question. No. Yeah, we just leave. Oh, yeah, that's where I wrote in step 3. Multiply out the tops. It's just tops. Yeah, we never multiply out the bottom. I mean, it's not illegal. You could. There's nothing wrong. But there's no benefit in it. It's just a waste of time.
Yeah,
So,
yeah.
so it's okay, but it's not necessary. Whereas the top is necessary. We have to gather like terms from 2 different numerators. Questions on that one?
Would you get it wrong if you have a 5V in
It's
back?
because, yeah,
No, yeah, good question. The order doesn't matter. If you put the 5V back here into the front, that's totally good. Yeah, the order doesn't matter. The order in which things are multiplied never matters. So just think about numbers. 2 times 3 isn't any different than 3 times 2. It's 6 either way you do it. Same thing with 5V and V minus 9 either way.
Or the minus 54 plus 41B.
True. Good? Yeah.
So, is the reason why I didn't have 5 squared minus 45 because as a number turns to be 75, is that just...
Oh, the reason I didn't multiply out the bottom? Yeah, I mean, there's nothing wrong with it. You totally could. And they might even show it that way on the multiple choice answers. So I hope I'm not being confusing. It's okay. it's just of no help whatsoever. So I wouldn't bother with it. But it's okay. Like if you wanted to make the bottom 5v squared minus 45v, that's also okay. I'll say or. Both are fine. It's not wrong. But it'll never help you do anything. So that's why I wrote in step 3. You can put this on your 3x5 card. Multiply out this
The
time.
thing, when you live in a
Just so to help you
where
remember,
they come
as soon as you've got common denominator, right? As soon as I see that those two denominators match,
Yeah,
I'm
that's what I
done.
thought first.
Yeah,
You
I don't multiply
cancel
anything, I don't
the
gather
these
anything,
one
I'm
with these one,
done.
but they are
So
rules,
once you
you
got
can cancel
common
that one.
denominator on step 2, you're done with the denominator.
If
You're
they
done
were inside the
doing
parentheses by
anything.
itself, then you
Now all
can
you're
cancel
working
it when
with
you
is
factor it.
gathering like terms and all that. So you don't need to. But I don't want to say it so strongly that I make you think it's actually wrong.
I like to remember.
It's not wrong. On the multiple choice exam, if you take, I grab the answers off the publisher's thing. Sometimes the publisher answers do show that in the bottom. So if they happen to do it, grab it. It's the same answer. It's not wrong. It's just of no benefit to you. Math Excel will take it either way. Math Excel knows that it's it'll take it either way. But my main concern is that you're not fooled on test day.
You can still taste it.
You know they're the same. There's multiple choice options. They're both fine. There's no benefit in doing it. Once you've got common denominator, no need to mess with the denominator anymore. The reason we have to, you might wonder, why do we have to do the top and not the bottom? Well, it's because there's two different tops, huh? The two tops are not the same. They're not common tops, right? They're different. So we have to multiply them out and gather them, you see, because they're different. Where on the bottoms, they're the same. We made them the same. There's no need to mess with the bottoms. They're the same. They're done. But the tops are different, so we have to multiply up there and gather to see what becomes of the top. That's why. Okay, there you go. Same kind of thing. Multiply top and bottom by whatever's missing. And those are packages down there, aren't they? X minus 15, inseparable package. X minus 4, inseparable package.
Okay.
So basically, you're just going to multiply by the other denominator, right? Top and bottom. Making some sense? So top and bottom of that one by x minus 4, right? Top and bottom of the other one by x minus 15. Is that good? Basically multiplying by the other denominator. So now notice the two denominators now match, huh? The order doesn't matter there. They have the same two parenthesis things. So we can forget about the denominator. It's good. You can put it in either order. Doesn't matter. And now do all your work in the top. So multiply out the two different numerators. Oh, let me give you some help. I would let this minus sign just go right on that x. Or, I don't know what you want to do there. But here, maybe I should take it slower. It's going to be 2x times x minus 4 minus x. I should probably just show you that. That'd be easier, huh? Do that. We're not done. But now, right, because that's 2x times x minus 4. And minus x times x minus 15. And then just distribute, gather like terms. Right, we still have more work to do in the top, right? Just keep going. Is that okay? Does that make sense?
Right there, oh yeah, no, but they are inside the parentheses, so you can cancel each other now, or you can?
Oh, yeah, no, don't worry about that. Just stay with this. My main answer to that would be stay with the steps. So where are we at in our steps?
Keep going.
Yeah, so remember you're supposed to, so I think the steps will really help you. Maybe I should be writing the steps out more. So this is, this is step 2. Multiply top and bottom by whatever's missing, right? And then this is step 3, what? Multiply tops, gather like terms. So we're not even thinking about canceling anything right now. right? We're gathering like terms at the top. The technical answer is you may not cancel. It's not just an order thing, but I think it'll be easiest for you to just remember the order. But if you want a full technical answer, this minus sign is gluing those things together, saying, don't you buy part of the package. Right now, that whole numerator is one big package because of that minus sign. But anyway, whatever. Just don't even, probably that's confusing. Just keep moving. Step 3, you're supposed to gather like terms in the top, right? So just keep right on moving with gathering like terms in the top. So we get 2x squared minus 8x minus x squared plus 15x. We good there?
We get the 8 from here, from the first one.
We good?
And then we added.
So that 2x went to x and minus 4. And then minus x went to x and minus 15. And then, let's finish it from here. 2x squared minus 1x squared. X squared minus 8x plus 15 is plus 7x. Over x minus 4, x minus 15, done. Now, could I take out an x on the top? Could I? Yeah, but who cares? It's not going to cancel anything. We're done. Now, remember, last step is to try to factor the top, but it's useless. It won't go anywhere. Right? You take out an x. They have a GCF of x, but so what? So nothing's going to cancel. So we're done. Good. Okay, so there we go on number 14. So step 1. So just try to stick close to those steps. That'll help you. Step 1. Factor where? Do you remember? Yeah, we start. Our focus is on the bottoms first off, right? First 2 steps are all about factor denominators. Step 1.
Oh, okay. So 13 total. Parentheses, x, 3 and 4, no? 3 and 4, and it will be minus and minus. Yeah, minus and minus.
Minus and minus?
Mm-hmm. And then we have minus 4 over x minus 4, and then we multiply it times x minus 3, 4. So following the rules, without them here.
All right, I'm going to factor that denominator with you. So, all right, so going to factor. This one factors x, and then how do they multiply? Remember, they got to multiply to be 12. What 2 numbers multiply to be 12?
3 and 4.
Yeah, 4 and 3, right? Remember the FOIL, F-O-I-L. And then what signs do they need to make minus 7? Both negative, right? Both negative. And that'll multiply to be plus 12, so that's the right factoring. So let's rewrite that one. My pencil, my Apple Pencil just broke, so I'm struggling to like hold it together here.
Where'd you get lost?
All right, so that's going to become x minus 4, x minus 3, 13. Whoops, sorry. Kind of scribbly there. Kind of write unnaturally. Minus. So we good to there so far? So there's step 1, factor denom. Step 2, give them what they're missing, right? And so this guy is missing something that his neighbor has. What's he missing? X minus 3. Okay, and now the 2 denominators match. So we can make it one big fraction. 13 minus 4 times x minus 3.
plus 12
That good so far?
minus
All of our work's in the top now, right? So we go 13 minus 4 goes to both minus 4x plus 12 over x minus 4, x minus 3. We get to there. And then last step, we're supposed to gather like terms in the top up there. What's up there in the top? What is that? 13 plus 12?
25
So that's minus 4x plus 25. Sorry, my writing's not the best here. Over x minus 4, x minus 3. Is that good?
that was carrying
Wanted to squeeze in 15. I guess I'm not going to get 15 done. My problems here. All right, let's stop there.